Hello, good afternoon, and welcome. Oopsies. All right. Hello, good afternoon, and welcome. And thank you all so much for tuning in to the very first test flight of our Hera 3 rocket. This next generation heavy lift launch vehicle has been months in the making here at Mythos Technologies, and we are so excited to show you exactly what it's capable of. We've run countless simulations and performed a plethora of pre-launch testing to ensure an entertaining inaugural flight today. So here at about T-minus 7 minutes before liftoff, let's take a moment to review the testing campaign which led us to where we are today. Test number 1 was conducted using one E12-0 and one D12-6-0 for a combined total of 2 motors. The test was completely successful and proved that we could, in fact, reliably ignite 2 motors at once. Test number 2 was conducted using 2 E12s and 1 C-class motor, totaling 3 motors. This test yielded varying success, with only 2 of the 3 motors igniting and the forward closure experiencing an unplanned burn-through. Despite these failures, we still collected critical data which informed our final decision to ultimately use 2 motors on the booster instead of 3. Now let's move on to our igniter tests. The first dual igniter test was performed before the first dual motor static fire in order to address ignition problems we were encountering during this time. The test was successful in this regard and allowed us to perform the aforementioned first ever dual motor test. Following the static fire test campaign, we conducted 4 additional dual igniter tests to ensure that both igniters would light at the exact same time within the expected margins. 3 out of the 4 tests were completely successful, and although this is well within our expectations, we decided to perform 1 more test to improve these margins. Now that you understand the testing and analysis that made our Hera 3 rocket a reality, let's take a moment to review Hera 3's capabilities and flight profile from a statistical and data-driven standpoint. As mentioned before, we ran countless simulations on the rocket with a handful of different configurations and external conditions, which gave us a pretty good idea of how the vehicle will perform on today's test flight. So with that being said, let's go over Hera 3's expected flight profile for today with the help of a little graphic to visualize the simulation's data. At T0, the Hera 3 booster will ignite its two E12 motors, generating a total force of approximately 66 newtons. After about 2 seconds, the first stage motors will burn out and hot stage separation will occur. The upper stage will cruise on an F-15 motor up to its apogee of about 550 meters, while the booster will tumble back to Earth. At its apogee, the second stage's payload section will separate, revealing its parachute, and the stage will glide softly down to a touchdown about 2 minutes after liftoff. Now, you may have picked up on a little detail about stage separation that was briefly mentioned during this flight profile review. And that detail is, yes, we are indeed using hot staging as this vehicle's stage separation mechanism. As you may already know, hot staging is the act of igniting the upper stage of a rocket while it is still attached to the booster. But the version of hot staging used on our vehicle is actually quite different than that used on other vehicles such as SpaceX's Starship. So let's walk through exactly how we plan on using our variation of hot staging to ensure a successful upper stage ascent profile today. This graphic shows, as you can see, the interior workings of Hera 3's booster, as well as the booster and upper stage motors. When the two booster motors burn out, an ejection charge will fire out the top. Flaming hot debris from the charges will be directed through the forward closure and guided into the second stage motor by an angled overhang at the top of the booster. Motor lights, the booster is jettisoned, and the upper stage sets off on its ascent toward the skies. Now, the thing about this method of staging is that the hot gases from both the ejection charges and the upper stage motor exhaust need somewhere to escape. Otherwise, the booster and inner stage will overpressure, resulting in a rapid unscheduled disassembly, otherwise known as an explosion. To combat this, vents have been added on both the inner stage and above the booster's forward closure to ensure the pressure of stage separation has somewhere to escape. Finally, before I leave you all here waiting for liftoff, I want pouring of support for the Hera program. Not in there straight. We're in a hold period right now. I'm not holding for anything. We're in a hold.
You can fast forward the timer.
I'm gonna come back in at T-minus 1 minute.
Cow, that's really tall. I might actually, because if that tips over, it's not super stable.
That's what I mean with the...
You're not doing the drone?
Nope. Press. Unprofessional screen. Okay. Unprofessional screen. Okay. Recording. All right, y'all. So sorry about the unprofessionalism for this stream. Was really hoping to run a more professional stream today, but we are going to resume the count here at T minus 1 minute and 30 seconds.